All right, so today we're gonna review, um, you know, trigonometry on a Cartesian plane. Uh, let's see, something like that. Anyway, from grade 11, you might remember a couple key things. Let's review them. So, cast rule, right? Cosine ratio angles are going to be positive in all, and cosine, sine, s and a, tan, t and a. This is quadrant 1, 2, 3, 4. Remember that in an angle in standard position, the initial arm is along here, the right of the x-axis, and then your terminal arm is going to be like here, there, or wherever, and then this angle here is your angle in standard position. The only difference now is that any angles we use are going to be in radians instead of degrees. So, this angle will be in radians. These boundary angles will be in radians. So this will be 0 radians or 2 pi radians when you go 1 full revolution. This is going to be pi divided by 2 or 90 degrees, pi for 180, and this will be 3 pi divided by 2. You might also remember that, this kind of thing applies when the terminal arm is rotated counterclockwise, but when it goes clockwise, you get negative angles. So this would be negative 90 or negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Now don't forget this is a coordinate plane. So obviously this will be your positive x, this will be your negative x, this will be your positive y, and your negative y. And you're usually given like a point, like a -1. Shoot. You're usually given a point, and then you can use that point to make the required triangle. So like, I don't know, -1, 1 would be like over here or somewhere. It doesn't really matter, right? And then you'll make a freaking triangle. Okay, holy moly, right there, right? And 1, 1, and then obviously your x value will be -1, y will be will be 1, and then you can find your hypotenuse, find the related acute angle, yeah, all that jazz. But how do we find the related acute angle? Well, I'll guide you through. So usually we're gonna use the x-axis and not the y-axis always, always, all right? What do I mean by that? So, in this quadrant, your angle will always be acute anyway. But let's say your angle is, right here, and we want to find this angle. We'll use 180 or pi, right, subtracted by this angle, and that gives us this angle. Same thing if the angle was like um, over here, right? Shoot. Excuse my terrible drawings. I'm not really used to using a graphic tablet yet because I don't use it that much. But anyway, you take this obtuse angle, subtract by 180, and that gives you this angle. And if the angle was, we extend it all the way here, right? We would take 360, subtract by this angle to find this angle. So that's how you find the related acute angle. So I don't like that. Yeah, okay, something like that, right? Right. So you're gonna be given something like, I don't know, a ratio So sine or cos or tan or even secant, cotan, cosecant. Okay, let's go over that. So let's see. So secant is basically the reciprocal of cosine. Cosecant is basically the reciprocal of sine. And then cotangent is essentially the reciprocal of tan theta, but it could also be um, cos theta over sine theta, because tangent is equal to sine theta over cos theta. Okay, let's try out a simple question. We're given the point 6, -1, and we're going to try and find the related obtuse angle, right? So, first off, you have the point right here, 6, -1, right? So your y value is obviously going to be -1, your x value is going to be negative, no, not negative, your x value is going to be +6. So those are the two side lengths of the triangle. And then what we're trying to do is find this angle. I don't know what the hell to call it, TA or something, or actually just A. Yeah, all right. And this will be theta. So, what we can do to solve this is to find this angle and then just take 2 pi and subtract that angle. So to find this angle, we can obviously use our primary trig ratios, right? We have the opposite and the adjacent, so tan theta equals -1/6. And then obviously you punch this into your calculator, uh, tan inverse. There's no exact value for this calculation, so I'm just going to approximate it to um, -0.7. And when you do this calculation, make sure your calculator is in radians and not degrees or gradients. Each calculator will be unique, so you'll have to find the button. But anyway, now we have that, right? That's the angle, so now we're just going to take 2 pi minus that, right? You punch that into your calculator again, because how you're gonna do that in your head. Well, actually, no, you're smarter than that, so I'm sure you could do it in your head, but if you can't, just punch it into your calculator. We get roughly approximately 6.45 radians. So that's that's A. Yeah, simple. Okay, two more things and then I think I can wrap up this lesson. So what if we want to find the positive angle and we're given the negative angle? So let's say we're given -6 pi/5, right? If you do the conversion, right, to degrees, that equals 216 degrees. So you'll know that it'll be in the second quadrant. That's a terrible drawing, but yeah, that's -6 pi over 5, and this is -pi. So, to find this angle, we're going to want this acute angle, right? We can use that to find the positive angle. So to find this angle, we're just going to do negative pi, no, negative 6 pi over 5 minus negative pi, and that just equals negative pi over 5. And then when you convert this angle to degrees, you don't have to, but it'll be easy to visualize. You'll see that it equates to negative 36 degrees. You know, negative 36 degrees. So now we can, to convert it to positive, we'll just take 180 because this is in the second quadrant. And if we want to find the related acute angle of a positive angle, we'll take 180 minus whatever this angle is, right? So take 180 plus negative 36, because adding a negative number is basically the same thing as subtracting a number. So 180 plus negative 36 equals 144 degrees, right? And then obviously to convert that to radians, we'll take 144 degrees and multiply it by pi over 180, right? And then you'll get 144 pi over 180, and then you simplify the fraction 144 over 180, so that 12 pi over 15. And then you can reduce it down further by dividing each number by 3. So, you know, the positive equivalent angle of negative 6 pi over 5 is 4 pi over 5. Now, another small thing too, hang on. So, you have pi over 2 here, 0, 2 pi, 3 pi over 2, and pi. When you have a point on the axis, right, on the axes, one of the values will be 0, either the x or y. So on here, your x will be 0, and your y will be positive. This will be, your x will be 0, negative y. Here, you'll have a negative x, and a 0 for the y, and you'll have an x and y here. Now, when you form a triangle on a Cartesian plane using a point, right? So this will be your point. The x distance is equal to the x value of that point, and your vertical sort of side length is equal to the y value, and then your hypotenuse is, well, your hypotenuse. So as you can see here, let's say this is the angle, right? As you can see here, when you take sine, you'll be doing y, like sine theta equals y over h, cos theta equals x over h, and then tan theta equals y over x. But then when your point is on the axes, right, one of the values will be 0. When your point is on the either axes, your hypotenuse is non-existent. It's not 0, it's non-existence. It's not there. How many times do I have to say that? So anyway, so if your point is on the y-axis, your primary ratios will go as follows. Sine theta equals y, cos theta equals 0, and then tan theta equals undefined, because y over 0, well, if you divide anything by 0, it will no longer, that's not possible. If your point is on the x-axis, it'll go like this. Sine nope, sine theta equals 0, cos theta equals x, and then tan theta equals 0 as well. I think that's everything. So just apply these skills, I guess. Yeah. Um, as always, please leave your thoughts below. If you need a summary of this, I could probably make one. But yeah, thank you for watching.